Hi students, let's look at this question here, which is on APGP. I believe this question was taken from ASRJC tutorial. Let's say I can do this proficiently. So a geometric series G has a common ratio of R, and an a metric series has a non-zero first term of A. The first three terms of G are equal to the seventh, third, and the first term of A respectively. Show that 2R squared minus 3R plus 1 equals to 1. Okay, great. So I think the first thing is to understand first. We were given that the AP, the first term is A. So I'm going to start with AP first, then the second term, then the third term, and up to the seventh term, right? We were told that if we were to take the seventh, this is the seventh term here, then the third, and then the first. Okay, I use T as my AP here, so I'm going to let D be the common difference of A. Okay, so there you go. Now we were told that this will be a consecutive terms of GP, so meaning taking the last one here and here, okay, but in reverse order. Okay, so I'm gonna write this out as A plus 6D, comma A plus 2D, and then the first term, which is A. Now we know that over here is multiplied by R, over here is multiplied by R, right? Okay, in other words, this guy here is A divided by R, because you just divide by R. Then here, over here, divided by R also. So this case will be A plus 2D divided by R squared. Okay, so from here, this will mean that A over R is equals to A plus 2D. All right, because this is equals to this, and after which this is equals to A plus 2D over R squared is equals to A plus 6D. Okay, I just want to include R squared and R together. Now this case here, what we need to do is just move the A to the other side. So moving the A to the other side will be this case. So similarly with this one over here, what I'm gonna do is sorry, this is not, this is AR squared. Okay, I wrote the wrong one. So we just divide A divided R with AR divided R with AR squared. So simplified here, this will be AR squared. Okay, so then here AR squared minus A equals to 6D. Then factorize the A out. What we need to do is to, factorize the A out. R squared minus 1 equals to 6D. 1 and 2. What I'm going to do is then divide the first equation second, because then after which we can cancel out the A. Essentially, what I want is R squared and R to be in one equation there. Alright, so taking 2 divided by 1 will be A 1 R squared minus 1 over A 1 over R minus 1 equals to 6D over 2D. Cancel off the D, cancel over the A. What is left behind is 1 over R squared minus 1. 1 over R minus 1 equals to 3. Okay, cross multiply both sides. R squared minus 1 equals to 3. 1 minus R minus 1 could just multiply by R squared both sides as well. This will be 1 R squared, 3 R minus R squared. Then if you just expand all this out with 2R squared minus 3R plus 1 equals 0. Okay, there you go. So shown, the first one, I've shown it, the first part. I think from the second one onwards will be quite okay. So deduce that G is convergent, meaning to say we want to see whether mod R is less than 1, right? So the multiplier of each term is actually less than between minus 1 and 1. So this case there from 2, so this will be 2R squared minus 3R plus 1. What you do is just factorize this, or just key in calculator to find the roots. So it'll be minus 1 equals to 0. So R goes to half or 1. Reject, as R is not equals to 1. We're told that it's not equals to 1 here. Alright, it's not a constant term. So since mod R is less than 1, mod R is less than 1, thus sum to infinity exists, and hence G is convergent. Okay, it just show that it's convergent, that's all. So part 2 done. So find the sum of infinity of the even numbered terms of G in terms of A. Okay, great. Sum of infinity, okay, great. I think the main thing is to find out what's our D, because now we do not know. So okay, we can just quickly find out D. Because now the first, we need to find in terms of A, right? That's the main thing. So okay, I'm just copy that down. So these are the terms here. So what I'm going to do is actually just find out what's a D, because I need to express in terms of A. And I know A over A plus 2D, this is a common ratio, right? And now essentially this is equals to half, which is what we had. Then we just cross multiply A plus 2D is a common ratio. So I took this divided by this to give me my R, which is half. All right. Then this is essentially A equals to 2D. That's pretty okay. So meaning this GP, the first term is A plus 6D. So meaning to, so this D is equals to half A. So A plus first term is actually A plus 6D for the GP. A plus 6 half A, which is actually 3. So it's 4A actually. So GP is 4A, the first one. Second one would be just 2A, A, because every term we just multiply by half, right? Then half A, and so on. 1/4 A. Okay, just keep going on. Now this, just take note, sum to infinity of the even numbered terms of GP. Even numbered terms meaning this over here. Okay, we're taking out even. So taking out even numbered term. Okay, what gets 2A, half A, 1 over 8A, and so on. Okay, 1 over 2. Yeah. So essentially now the even numbered terms is over here the R is 1/4, because you skip by 2 terms here. So it will just be 1/4. Here over here will be 1/4 as well. Okay, all the common ratio becomes 1/4. So the sum of infinity, even numbered terms, the formula is A 1 minus R, right? So the first term is 2A, because the second term, we start with the even numbered term, meaning this is a U2, U4, right? We start with U2 first, so 2A. So if you take a fixed periodic interval from a GP, it will still be a GP. Similarly, if you take a fixed periodic, like let's say even number term, or every 3 terms you take it out from an AP, it will still be an AP. So that's the concept there. So this is 1 minus A with 1/4. So you just key in calculator and you'll get your answer. Answer is, so you just key in, this will be 2 over 3/4. That's 8 over 3A. Okay, so that's how I do this question proficiently. If you have any questions at all, please let us know and I'll see you in the next question.